All right, welcome to another episode of the Green Ninja Climate Science series. In this video, we're going to be talking about what are the potential impacts of climate change. There are many reports that have dealt with this in a very detailed manner. The last IPCC report had an 1,000-page section on the impacts of climate change. So in this brief video, we're just going to touch on some of the major themes. First of all, I think it's important to note how big of a change we're talking about in terms of temperature relative to what we've experienced in the recent past. So here's the past 1,000 years of temperature from the year 1000 to up to 2011. These are our best estimates from proxy reconstructions as well as the instrumental record over the past couple hundred years. And we see then projected out into the future are different scenarios or our best guess of what the temperature will do if humans continue to increase greenhouse gases in a kind of business as usual situation. And I think I mentioned in the paleoclimate video that the Earth has actually been warmer in the past than we're expecting it to get by the year 2100. But this rate of warming is what's really concerning. This rate of warming is probably larger than anything the Earth has ever experienced, except for maybe a situation where you had a climate change based or coming from a meteorite impact. But other than that, this rate of warming is extremely fast, and it's too fast for a lot of natural systems to be able to adapt to, and it may be too fast for a lot of human systems to be able to adapt to. So this is really what's concerning. So we talk a lot about absolute changes in temperature, and I just want to make that a little bit more concrete by showing the changes in temperature at two locations. So what we're doing is we're not looking at projections here. We're looking at actual data from the past for both the city of New York and the city of Washington, D.C. And what I've done is I've lined these graphs up so that the lines going across are of equal temperature. So here's 12 degrees Celsius in both graphs, here's 11 degrees Celsius in both, and here's 10 degrees Celsius in both. And what you can see is that New York, at the beginning of the century, was down around 9 degrees Celsius, but they have warmed to close to 11 degrees Celsius. Now Washington, D.C. started out near 11 degrees Celsius, and they have warmed to around 13 degrees Celsius. So what has essentially happened is that the climate of New York has you can think of it as it has moved south by a couple hundred miles. So Washington, D.C. is a couple hundred miles to the south of New York, and so just over the past 100 years, New York's climate has moved to the south. And now over the next century, we're expecting climate change to continue, if not to accelerate. And so New York may end up having a climate like North Carolina did in the 20th century. And so when you start to think of it in these terms, you can really kind of appreciate the magnitude of what we're talking about in terms of climate change. I mean, the different agriculture and the different societal issues that come with these different climates are big. And so when you're moving a city's climate hundreds of miles to the south, that's going to have big consequences for that city. Another point I wanted to make is that we talk a lot about increases in mean temperature. So what's the global mean temperature going to be like? What's the mean temperature at a given location going to be like? But it's important to note that small increases in the mean of a temperature can have big increases on the extremes. So just to illustrate that, this is just a schematic diagram where we're showing the distribution of temperature in some location where you have most of the occurrences of temperature are right near the average, and then you have a bell curve where you have less and less occurrences at extreme cold and less occurrences at extreme warmth. And now we're talking about a situation where we moved the climate to the right, or we've warmed the mean of the climate. And so you can see that these two bell curves overlap quite a bit. So you get a lot of the same temperatures you did before. However, you get this huge change in the extremes of temperatures. You get way more record warmth than you did before, and you get way less record cold than you did before. Even though in this case you can still see that you still get temperatures that were below average in the previous climate. But most of the change comes in the extremes, even if it's kind of a small change in the mean. And so we've seen this already in the instrumental record. So this is the ratio of record daily high temperature set in the United States to daily low temperature set in the United States. And we can see that, say, in the 90s, the ratio was 1.36 to 1, or there were 36% more record highs set than record lows. And by the 2000s, it was over 2 to 1, twice as many record highs set as record lows in the United States. And that is just continuing to increase. That ratio is expected to get close to 25 to 1 by mid-century. But that doesn't mean that you don't get record cold. You still get record cold because of weather, but the ratio is just extremely skewed, where you get way more record warmth, which really has devastating consequences when it comes to droughts and heat waves and things like that. That can really affect crops and other natural and human systems. So we talk a lot about temperature, but precipitation is also another thing that's expected to change. So this is a computer model simulation of what precipitation change might be like in the 2090s relative to today. And so what they're showing here is changes in precipitation percentage. So these yellows and browns are negative changes, so that means drying, and the blues and greens are areas that are expected to get wetter. And so it's interesting to note that a lot of the Earth does get warmer or wetter, and we're looking at winter versus summer here for the northern hemisphere. And so that could have some positive impacts in various regions. But when we take a closer look, actually, and this is a measure of drought in the 2090s, also from a computer model simulation, we see that drought is actually expected to increase over the vast majority of the planet, so, or at least the vast majority of the land surface. And so we can see that in areas that are expected to get less precipitation, this makes sense. But even in areas where we're expected to see a little bit of an increase in precipitation, we're still expecting to see an increase in drought in those regions. And that's because precipitation is expected to fall in much more concentrated downpours than it did under the previous climate. So, when you used to have a summer where, let's say, it rained 6 times in July and it was light rain every time, the new climate might be a situation where it only rains twice, and so you have a lot more days in between with no rain. And during those 2 rain events, you have a lot more rain. It's a lot more intense. So you can actually have simultaneously more floods and more droughts at the same time. And it's really not a contradiction to have that. And so what our best estimates are saying is that a lot of the Earth's land surface, at least, will experience these drying drought conditions by the end of the century if humans continue to emit greenhouse gases. So another big issue is sea level rise as we're melting ice that's on land, and as we're increasing the temperature of the ocean and having it expand thermally, the water level increases. And so by the year 2100, we're expecting about 1 meter of sea level rise or more compared to what it was like in 1900. And so that's 3.3 feet vertically, not horizontally. So depending on where you are, 3.3 feet vertically can inundate quite a bit of land inland. And that's just the beginning. We're expecting, because there's these huge time lags in the climate system, we're expecting sea level to continue to rise quite a bit out for hundreds of years, where by the time we're looking at 2300, we're talking about in the range of 10 to 16 feet of sea level rise, which is really going to start to change the shoreline of a lot of major areas where people live. Here's a kind of a summary diagram of different impacts on different systems based on, this is from the IPCC. And the way that they have organized this is with 0 degrees warming, 1 degrees warming, 2 degrees warming, 3 degrees warming, 4 degrees warming, 5 degrees warming in Celsius relative to 1980 to 1990. And they're showing in these different categories, this is very broadly what we expect to happen for each one of these, or for varying degrees of warmth. So you see, like, for instance, in ecosystems, we're expecting significant extinctions around the globe if we cross 4 degrees Celsius. Right now, we're still under 1 degree, so we, hopefully have time to avoid the worst of the impacts. But a lot of, once we're up to around 3 or 4 degrees Celsius warming, we are expecting very negative consequences from that. So, here's another example of coasts. We have millions more people could experience coastal flooding per year. 30% of global coastal wetlands lost by 3 degrees Celsius. So a lot of potentially very negative consequences once we get up to that level of warming. So what are the potential impacts of climate change? Well, there are many, many impacts that we did not go into at all in this video. But for the most part, I would say that the bad definitely outweighs the good, and there could be a lot of damage done if humans continue to release greenhouse gases at the rate that they are.